Okay, today we're going to take a look at Chapter 2, Linear and Quadratic Functions, with Section 2.1, Linear Functions. In order to understand linear functions, we first have to understand the idea of slope. Slope is typically associated with a rate of change. And the idea of slope is that I will have 2 points, and I would like to know how I am changing as I go from one point to the other. Now, typically, we will think of this change in two separate ways. There will be a vertical change, delta y, and a horizontal change, delta x. We could calculate this change if the points are x1, y1, and x2, y2, by noticing that delta x would be x2 minus x1, and delta y would be y2 minus y1. Therefore, I can look at each of these changes by subtracting the coordinates of the points. For slope, what I'll want to find is the rate of change. That is, how quickly is y changing relative to how quickly is x changing. And we'll set that up as a fraction. This all comes together in this slope formula here, where m is equal to the quotient of y2 minus y1 over x2 minus x1. Now, this formula will not apply if x is not changing, because you can't divide by 0. So if the x is not changing, that's totally okay. The slope is simply undefined. In this case, the points would be directly above or below each other, because that was what we would need to have the x value not change. Let's go through and take a look at how we can apply this. The first way is directly into the equation of a line, and this is going to be the first of many formulas we're going to be looking at over the next couple of sections. Point slope form. The idea here is all I did is I took the slope formula from the previous example, and I multiplied the denominator both sides. And then instead of using y1 and y2 and x1 and x2, I decided to name one of the points simply x comma y for us to plug in. So by modifying the slope formula very slightly, I get the equation of a line. In this case, I've got a line where x1, y1 is any point on the line, and we will calculate m as the slope by using the slope formula. This equation is very nice because it gives us everything we need to graph it, and it's also often very easy to see this information from a graph. The slope you can count, and a point, it's very easy to find a point. Notice that there's a lot of points on this line, infinitely many in fact. Any one will do. It does not matter which point you pick. You will get a different but still correct equation no matter which point you choose. So take your pick. Let's find the equation of the line through these 2 points. The first thing I'll need to do is I'll need to find the slope. So m is y2 minus y1 over x2 minus x1, which in this case, I'll just have to pick 1 point to be each. So let's call this one x1, y1, and let's call this one x2, y2. In this case, that will give me 1 minus 3 over 2 minus negative 1. Make sure you include the negatives and that you're careful, because dropping negatives will give you an incorrect equation. I will get negative 2 over subtracting a negative is like addition, 3. I could also write this as negative 2/3. Now, first of all, the fact that this is negative indicates the fact that my slope will be downwards. I know that my line is going to go in this direction somehow. If I was thinking this in the traditional rise over run form, I could think of this as going down 2 and to the right 3. in terms of putting this into an equation, I can do y minus y1 is equal to m x minus x1. Now, writing minus -1 doesn't look very nice, so we would usually instead write x plus 1. Notice the fact that we have addition here indicates the fact that my point is actually negative. And this is exactly the same as when I have transformations. It's exactly where this comes from, in fact. Notice that I used the first point, but it would have been perfectly correct to use the second point. If I instead would prefer to write out the equation as y minus 1 is equal to -2/3 x minus 2, that would also work. Whichever point you choose is perfectly correct, and both of these are valid equations for this same line. If I was to graph this line, that goes through the point -1, 3, and 2, 1, the line would look like this. We can observe the slope here. Down 2 for the delta y, and delta x is to the right 3. So that's where we can see the slope show up. And again, either point is perfectly correct to use in the equation. Now, slope-intercept form is just a more specific version of point-slope form. This is probably the one that many of you are most familiar with, y equals mx plus b. Slope-intercept form is simply point-slope form where the point is an intercept. Y minus y1 is equal to m x minus x1. If my point is 0b, plugging this into my equation gives me y minus b is equal to m times x minus 0. Dropping the 0, I get y minus b is equal to mx. And then since I want to solve for y, I'll add b to both sides, obtaining the familiar form. There's a lot of reasons to use slope-intercept form. It's very nice because it identifies the intercept. Oftentimes the intercept is a significant point, especially in word problems. Knowing where the input value is 0 can often have a significant meaning when I'm doing a word problem. The other very nice thing here is that for y equals mx plus b, it's written like a function. I've got an input x and an output y. Writing it like a function is, again, a very helpful thing for word problems because I like to have an input and an output variable, an independent and a dependent variable. That being said, there may be times where slope-intercept form makes more sense than point-slope form, or there may be times where point-slope form makes most sense. We'll want to be familiar with both. Now let's say I wanted to graph the function given in slope-intercept form. All I will need to do is graph the intercept and then graph another point by using the slope. So after labeling my axes, I will begin with the point up here. 0, 4, which I identify because b is equal to 4. I will then take a look at the slope. -3/2, I'll take the negative and put it on the top. That means that I can see that my delta y is equal to -3, and my delta x is equal to 2. So what I need to do is I need to go down 3 and over 2. Recall again that what I'm thinking of here is rise over run. And since my rise is negative, it's actually a fall, so I'll be going down. Down 3 over 2. There are my 2 points, and I'll simply draw a line between them. Always when we graph a line, I want to see 2 points plotted and labeled. So in this case, 2, 1. That's all we have for this section. I'll see you guys next time.